We're going to have a look at the trend in boiling points of alkanes. And just remind ourselves that boiling point is a physical property, and we're going to look at how the boiling point changes as we increase the number of carbons in the alkane chain. So over here I have a graph. So it is number of carbon atoms plotted against the boiling point. And I've just got that information down here as well. So whereas one carbon, that is methane, then we've got ethane, propane, and so on. And the same thing down here, just got methane, ethane, propane, and so on. And as you can see, as you increase the number of carbon atoms, the boiling point is increasing. And anything that has the boiling point below room temperature, so room temperature is around about here, anything that has a boiling point below that is found as a gas. So that tells us that methane, ethane, propane, and butane are found as gases at room temperature, and going above that, so pentane onwards, is found as a liquid at room temperature. And all of these kind of boiling points are or that having a different boiling point is quite important when it comes to something called fractional distillation. So you would have looked at fractional distillation back at GCSE, and it's where you separate the different components of crude oil based on their boiling point. So that's why, all of these alkanes having a different boiling point is quite useful, because that means we can separate them in fractional distillation. So the next thing to know is why does the boiling point increase as we increase the carbon chain? And the reason behind that lies in terms of London forces, the intermolecular forces. So over here I have a small chain alkane, so this is propane, it's got 3 carbons in it. Then we increase a chain to butane, and then finally to pentane. So as we've just said, that as we increase the carbon chain, the boiling point is increasing. And the reasons behind that are because as we increase the chain length, we have a larger surface area. And because we have a larger surface area, we have more surface points of contact. So between the molecules, we have more points of contact. And also, because we're increasing the carbon chain, we're increasing the number of atoms, we're also increasing the number of electrons. So as we increase the chain, we have more electrons. So having a larger surface area and more electrons, they both contribute to the fact that we therefore have stronger London forces. So between our molecules, we have stronger London forces as we increase the carbon chain, and that just means we have more energy. That means we need more energy to break those London forces, and that means the boiling point increases. So you should, if you are asked this in an exam, you should address all these key points, explaining why the boiling point increases as you increase the carbon chain. Right, another thing to address is what happens to the boiling point as we increase the branching. So these molecules over here, so this is pentane, that is C5H12. This one here is 2-methyl butane, which is also C5H12. And this one here is 2,2-dimethyl propane, which is also C5H12. So they are structural isomers of each other. In terms of the number of electrons, they are exactly the same because we have, the same molecular formula. So what we want to learn is as we increase the branching, but keep the molecular formula the same, as we increase the branching, what happens to the boiling point? Okay, so as we increase the branching, what happens? So going across these, we are obviously increasing the branching. And that means because we're increasing the branching, we actually have fewer surface points of contact. Okay, the branches kind of get in the way, and that means we have fewer surface points of contact. And that means we have weaker London forces. So you increase the branches, fewer points of contact, therefore weaker London forces. So that means you need less energy to break those London forces, and therefore the boiling point decreases. So as you increase the branching, the boiling point is going to decrease, and these are the points here that you must address when talking about the boiling point decreasing as branching increases.